Okay, so these are the topics for BC Calc test on chapter 6. We've been working this for a few weeks now. You basically have 4 topics in here. First, the whole idea of an integral function. And the fundamental theorem of calculus part 2. How do you take derivatives of integral functions? The second topic we did was the derivatives and integrals of exponential functions. Concentrating on e to the x. E to the x, that's the most important exponential. The third topic was derivatives and integrals related to the natural logarithm function. And again, we were doing the derivative of the log function, but it was 1 over x, and the integral of 1 over x was the natural log. So more examples on those on the next slide. And the last topic we covered was L'Hopital's rule and limits involving indeterminate forms. Okay, so a quick page on each one. First, integral functions. We need to be able to evaluate them. Let's say f of x was defined as an integral from 3 to x of t minus 1 dt. And you're asked to find f of 0, f of 3, and f of 9. Okay, like every other function in algebra, you're going to take the input and put it where the x is. So f of 0 becomes the integral from 3 to 0 of t minus 1 dt. And this is some number that you can calculate. Remember, definite integrals lead to numbers. So using the fundamental theorem of calculus part 1, we need the antiderivative of t minus 1 dt, which is t squared over 2 minus t. And we're going to evaluate that between 3 and 0. And the method we had for that was, remember, you're going to put the upper limit in first and then put the lower limit in second and subtract those two. So putting 0 in place of t, we get 0. And putting 3 in place of t, we get 9 halves minus 3. So the final value would be minus 9 halves plus 3, or minus 9 halves plus 6 halves, which is minus 3 halves. Okay, so f of 0 is minus 3 halves. Okay, f of 3. F of 3 is even easier. Let me put a little bit more room down in here. Okay, so f of 3, again, taking the input, excuse me, putting 3 in place of x up here at the top. Okay, we get now the integral from 3 to 3 of t minus 1 dt, and that should obviously be 0. Okay, don't need to evaluate this whenever you're integrating. Remember, integrating any function between the same upper and lower limits, any function here whatsoever, you're always going to get 0. Okay, so that one is a quickie. The last one we wanted to look at was f of 9, and we'll do that one. Let's see, f of 9 is the integral now from 3 to 9 of t minus 1 dt. We've already found the antiderivative up here. This was the antiderivative that we need, so t squared over 2 minus t, but now we're evaluating between 3 and 9. So parentheses minus parentheses, put the 9 in, we get 81 halves minus 9. put the 3 in, we get 9/2 minus 3. If this were a free response question in May, you could leave it here. You don't have to do any simplifications, but this is an easy enough problem to deal with. 81/2 take away 18/2, take away 9/2, and now don't forget to distribute, so that would be plus 3, which is plus 6/2. And adding these up, what do we get? 87 less 27, which is 60/2. So 60/2, what did I write? 6/0, 6/2, obviously, Joe. So we get, again, 81 and 6 is 87, 18 and 9 is 27, 87 less 27 is 60/2, which is 30. Okay, so this number here, which is this integral, is the number 30. Okay. Now, what else are you expected to be able to do with integral functions? You're expected to take the derivative. So what is f prime? That's a question mark. The derivative of the integral function. And again, we're going to use the fundamental theorem of calculus to do this, but we're going to use part 2. Let me pull up a new screen. Again, we had f of x was the integral from 3 to x of t minus 1 dt. And now the task is to find the derivative with respect to x of this integral function from 3 to x of t minus 1 dt. Okay. If we look in the text, you'll just note that this simply, you take the x and put it in place of the t, and you get x minus 1 done. If we modify f slightly, say we had g of x was the integral from 3 to x plus 2 of t minus 1 dt. And so I've changed the upper limit from x to x plus 2. And now we're asked to find g prime. G prime, again, this is the derivative of this integral function. Simply take that upper limit and put it in place of t. So this would be x plus 2 minus 1, which is x plus 1. Okay, one more modification, which will be rather interesting. Suppose we had h of x, which was the integral from 3 to x squared plus 5x plus 2. And again, our integrand is still t minus 1 dt. And our task is to find the derivative of this integral function. Again, take this upper limit. Let me grab a red pen. Take this upper limit and put it in place of t. But then after doing that, x squared plus 5x plus 2 minus 1, you always have to use the chain rule. So we're going to multiply this by the derivative of x squared plus 5x plus 2, which is 2x plus 5. And this would be our final answer. You could leave it that way, or you can distribute it if you like. The last possible scenario might be what happens if your integral function has variable limits top and bottom. So let's say 3x and x plus 2. And just to change things up, let's change the integrand to 2t minus the sine of t, dt. And your task is to find the derivative of this. Well, again, it's sort of like what we've done before. You're going to take this in place of the t. You are going to have to use the chain rule. So here's our answer. It's going to be 2 times x plus 2 minus the sine of x plus 2. So that's putting minus the sine of x plus 2. That's putting the upper limit in. We do have to multiply that by the derivative of x plus 2, but that just happens to be 1. But now we also have to consider this lower limit. We have to put that in. So we'll do that. So we're going to subtract off, now putting the 3x in. So we get 2 times 3x minus the sine of 3x. But using the chain rule, we now have to multiply that times the derivative of 3x, which is 3. And so that would be our final answer. It sort of looks messy. I suppose there's a little bit of cleanup you can do just to make it look a little bit more presentable. 2x plus 4 minus the sine of x plus 2. There's not much you can do there. I have this 3 coming around, and I have a negative sign. So trying to keep track of everything, it looks like we have minus 12x, and then plus 3 sine of 3x. And I suppose the minus 12x and the 2x can be cleaned up. So minus 10x plus 4 minus the sine of x plus 2 and plus 3 times the sine of 3x. It's sort of an ugly problem, but it does show the fundamental theorem of calculus, part 2. Okay, I'm going to stop the video here. I'll throw up another one with the other topics that are going to be on this test. And this is mainly for Emily and for Blake because they're not here today.